Sorry about that. When I plugged in my laptop, it just, yeah, something went wrong. All right, so let's continue again from where we left off. Right, so we were at right, so we are given the reasons why how we got A, B, C, and D. Right? Let me just recap D. C, like about state the type of isomerism exhibited by A and B. So both of them have the same molecular formula, but the functional group is different. So if the molecular formula is the same and the functional group is different, then it's functional group isomerism. So between compounds A and B, both of them have the same molecular formula, but one of them oxygen, right, with the two carbons attached to it. Alright, so ketone C double bond O, right, with two carbon atoms attached. The aldehyde, it is C, as you see here, C double bond O H, right, with a carbon. So two different functional groups present with the same molecular formula. So it's functional group isomerism. The carboxylic acid, and so the general formula for carboxylic acid is CnH2n plus CnH2 plus 1 COOH, excluding the COOH group, right? So Cn in this case, checking this formula, two carbons, right? So N is 2, so 2 is 4, 4, and we have two carbons, 3 and 2. So you can see that it matches the general formula. So this is the general formula for carboxylic acid. And that would have ended the first question. Alright? So it says most organic compounds can be placed in homologous series. Reconnecting. State two properties of a homologous series. So we know compounds in a homologous functional group, right? If they have the same functional group, that means they will have the same chemical properties. That means they do the same type of chemical reactions. So they have the same general formula, same functional group, right? Same chemical properties, and they differ by a CH2 group. This again, so part B, same empirical formula, but a different type of working out. So if you remember, if you had watched the 2016 past paper video I uploaded, it's a similar mixture of hydrocarbon, a mixture of 10 cm cube of a gaseous hydrocarbon. Right. So we have 10 cm cube of a hydrocarbon, multiply it CXHY, because you know hydrocarbons, right? So a mixture of 10 cm cube of a gaseous hydrocarbon. So we have our hydrocarbon CXHY, right? 10 cm cube of it reacts with oxygen, 100 cm cube, right? Was exploded. So this means it's combustion analysis. Once you react your hydrocarbon with oxygen, that is a combustion reaction. So they gave you the volume of the hydrocarbon and the volume of oxygen. Now, the volume after the explosion, meaning after the cm cube, right? And this was reduced to 60 and treatment with KOH, right? So again, the volume after the explosion was 100 and this was reduced to 60, right? And treatment with KOH. So KOH will remove the CO2. So the 60 cm cube that is remaining, remember we start out with not 100 oxygen, start out with, 120, right? But after the reaction, the 60 cm cube that they tell you is remaining, they could have said it was for oxygen, but they just tell you that 60 cm cube, it was reduced. No, the important part is KOH. So the KOH is to remove the CO2. So after the explosion, it was 100 and it dropped to 60. So the CO2 that is formed would be 40. So they start out with 120 oxygen, right? And they said that, so you start out with 120. After the explosion, you have 100 cm cube. After you treat it with KOH, you have 60 cm cube remaining. Now 60 from the 100, right? That difference, that is for the oxygen. So to get the overall, or to get the amount of oxygen that was used, to start out with 120 and 60 remain. It's reconnecting again. Oh, this is flow internet, by the way. If it's, yeah. Let me say flow, everybody know. Alright, so 120, 60 remains, right? So the total amount of oxygen, you start out with 120, right? And you leave with 60. So the actual amount that was used would have been 60. Alright? Now remember, this is combustion analysis. So you're supposed to get carbon dioxide. When they said a mixture of 10 cm cube of gaseous hydrocarbon P and 120 cm cube of oxygen, in bracket they put excess. So the excess means that it's complete combustion that occurred. So if it's complete combustion, you get carbon dioxide and water. Alright, so no. So this is how we do it first. Set out the question if you get it like this, right? So once you get volume of your hydrocarbon, volume of oxygen, and the CO2, this is how you set it out, right? Write your equation, because what we're trying to find out is what our hydrocarbon is. Remember, in the first question, we did the empirical and molecular formula, right? But a different way. This is a similar type of calculation, right? But the approach is different. But what we are going to do now is to get the moles of each of these. So let's see how we can approach it, right? And notice we don't have anything for water. Now compare these three numbers, right? 10, 60, and 40. The 10 here for the hydrocarbon, it can go into all of them in itself. So simply put, you can divide by the smallest one. So 10 divided by 10, you will get 1. 60 divided by 10, you will get 6. 40 divided by 10, you will get 4. Alright? Now, alternatively, what you could do is to find the mole of these. Remember, they said that in the question, it occurred at the same temperature and pressure, right? So we could use RTP. RTP, we know is 24 dm cube, right? So we could just divide everything here by 24 dm cube. Look what happens. I did that as well. So in the interest of time, let me just get the answer. Right. So this is what you do, right? Get the amount of moles first. So you can do it like this, or remember this is in cm cube, right? So you can convert it to dm cube. So 10 cm cube is 0.01 dm cube. And we do, remember it's RTP now. And so we just put RTP. So everything is going to be 24. 60 dm cube, sorry, 60 cm cube, 0.06 dm cube. Alright? 40 is 0.04. Now remember, mole, if you want the mole, right? Given the volume of gas, all you have to do is divide by RTP. If it's at RTP, or STP, if it's at STP. The question said the temperature and the pressure was constant, right? dm cube. So work with the 24, right? So the answers here we will get, where are the answers? 4.17 times 10 to the minus 4, that is for carbon. Wait, no. Give me a minute. Alright, let's do this. So 0.01 divided by 24, right? 4.17 times 10 to the minus 4. 0.06 divided by 24, 2.5 times 10 to the minus 3. And then 0.04 times the hydrocarbon, the oxygen, and the CO2, right? Then, just like we did in the other question, we divide by the smallest number. In this case, it's 4.17 times 10 to the minus 4. So 1.67, we get 4. Right? 2.5 negative 3 divided by 4.17 negative 4, get 6. Oh no, this is 1. Alright? So you can see that if you work it like this or work it like this, you have the answer. Alright? This way is much quicker, but I'm just letting you know that there's more than one way to. As you get, you divide by the smallest number. So compare the three of them and divide by the smallest number, and that's it. Alright? I'm going to wait 30 seconds in case I want to write it off. Alright, so I'm just going to wait a little. Alright, so once we work out this now, right? I'm going to erase down here and go back here, the 1, 6, and 4. So the first thing that we want to calculate is the amount of moles of our hydrocarbon, sum of the equation. Alright, so we now know that we have 6 moles of oxygen. So we can put the 6, right? And we have 4 moles of CO2. So you can put the 4 there. And we have 1 mole of our hydrocarbon. Now, if 1 mole of our hydrocarbon produces 4 moles of CO2, by simply balancing the equation, we're not really balancing, but as in it's present, if you get 4 moles of carbon dioxide, right, and you only use 1 mole of the hydrocarbon, then that means 4 carbons would have been present. 1 mole of 2, it has in 4 carbon atoms. So it's reconnecting, so that we wait it. Right. So if 4 moles of CO2, it has in 4 carbon atoms. Therefore, the hydrocarbon must have 4 carbons. All right. Now, let's look at oxygen. Means in terms of oxygen atom, if it's O2, right, and you have 6 of it, we would have 12 oxygen atoms. All right. Now remember, we know how many moles of CO2 we get, which is 4 moles. Now we have 2 oxygen present in 1 molecule of CO2, or in 1 mole of CO2. So 2 times 4, that is 8. So we start out with 12 atoms of oxygen, right? Carbon dioxide 8. So remember, this is the reactant side. This part is the product. So 8 from 12, that is 4. So the one, let's look. You balance this oxygen. So 6 twos, that's 12. So over here must have a total of 12 oxygen. We already balanced the C-words, that is 8. Right? We know 12 water. Okay. Right. All we need to do now, we figure out everything except hydrogen. Reconnecting. 4 2 C4H8 plus 6 CO2, 4 CO2 plus 4 water. Right? So our hydrocarbon is C4H8. Right? Now the laptop battery is dying again. I don't want to. I'm just going to take about 30 seconds. So our hydrocarbon is C4H8. Alright, so that's how you would calculate it. 22 minutes. Alright. Right, so compound P, right, so this is compound P. Compound P and C4H8, alkene or alkane? Anybody? Alright, it's alkene. So remember the general formula for alkene is CnH2n. It would have to be 2 fourths 8 plus 2, which is 10. So C4H8, that is an alkene. Correct, double that. That's your answers. Alright, so we know compound P is an alkene. Alright, it says to which it belongs to. So what we just did was 7 marks. We figured out the molecular formula, and we know it belongs to the alkene homologous series. Now for 4 marks, for part B, it wants the name and the displayed form. So C4H8 is butene. Right? And remember, when you have, okay, just a second. Remember, when you have a compound like alkene or an alcohol and you want an isomer to a different position. So in this case, it is between carbons 1 and carbons 2. So we know it is 1 butene. So to get the next isomer, we just shift the position of the carbon atom. 1 butene, if you want, you can say but 1. So those are the, so, right? So those are P and Q. All right. So the name on the molecular formula of P and the homologous series to which it belongs. The name and discrete formula of the isomer of Q. Given two reasons for your answer. Before we answer part B, let's go back. What's the reconnecting? See up to the point where I did all of this. It says reconnecting, so just let me know. Alright. Some Q on hydration. Now once we hear hydration, we know it's a key. So compound P is isomeric with compound Q. That means P and Q, one of these is P and one is Q. So both of them are alkene, but it says compound Q on hydration produces two compounds of molecular formula C4H10O. When you hydrate an alkene, you get one of these, you would get alcohol, right? But it says compound Q produces two compounds. Now, if you hydrate 2-butanol, if you hydrate 2-butene, what you are going to get is 2-butanol. So if you hydrate this, all you will end up with is this. Now if you put the OH here, it is going to be 2-butanol, right? Now if you put it on the next carbon, it is still going to be 2-butanol. So clearly, this cannot be compound Q, because when you hydrate Q, you're supposed to get two different alcohols. So therefore, this one is compound P, because when you hydrate it, so remember, the double bond is between carbons 2 and 3 for 2-butene. So the OH group, you can either put it here or here. And in both instances, alcohol. Because for this one, you are counting from this end, 1, 2. For this one, remember you always count from the end closest to the functional group. So you count from here in this case. So both of them is the same. They are not different. Alright, so this is compound P. 2-butene is compound P. When you break the double bond, do one next time we just do one where we just the alkene build one in the OH, it can go on any carbon, it can go on hydrocarbons, right? Now if it goes on carbon, now if it goes on the second carbon, you will get 2-butanol. Alright? Now this is a primary alcohol, this is a secondary alcohol. Good? And we know that primary and secondary alcohols don't react the same. Alright, I have 14% left. Just know. Pretty quickly if you want to do it tomorrow. Yes, no? I'm going to end the stream. Thanks for coming out, by the way. Hope you learn to pick up here and some more questions. Alright. I probably just do revision next week, alkenes and alcohols. So we'll go over the mechanisms and stuff so you can understand the past papers a bit more. Alright, so I'm going to end it here. Have a nice night. Is the video saved? I'm going to save it. I'm not sure if the first one's saved. Alright.